This meeting is being broadcast on Facebook Live.
And we are live. Okay.
Live. Okay. I thought I was going to beat you to this for having the Facebook Live going. I just need to push this one button here. Facebook Live, open hours. Okay. I think now we're good. All right. And 3, 2, 1. Everyone, welcome to 96 Boards, Open Hours, episode 101. As we have already declared, what was this, several weeks ago and throughout the last month, this is the beginning of phase 2. I have to apologize. It looks like my camera is a little off. Sorry. I'll try to fix this maybe in the next episode, but it doesn't matter because I hope to not be talking so much myself. I'm going to be handing the mic off to our first guest of the day, who is Joy. She's in the call. I'll let her introduce herself in just a second. But before that, we have some announcements, as always, to share some of the things that will be going on soon. First off is I want to remind everyone that we are doing a crowdfunding campaign for the 96 Board GPS mezzanine. I'm going to share the link here. This is the first hardware mezzanine that we have tried to get funded through a company called GroupGets. And it would be really nice if it got funded. I haven't jumped in and bought one yet. I don't have one. I was given one of the original prototyping boards that was pushed out, the first one. And yeah, I got to use that one, but I'm actually very interested in the second version of it, which they added a whole new section to it. They added the UR debugging, all of that good stuff. So if you want to get your hands on one of those, we are trying to fund it very within the next 2 months, right? So I'll probably end up going and getting one, but we need 25 funded, right? So it might take a bit. The next thing I have to share is something that Mani is working on and has achieved, which is mainline support for the, I'm getting my coffee handed to me here. I was late to brew it. Mainline support for the MediaTek X20 board. So one of our 96 boards that hasn't gotten much attention. Mani seems to like the boards that don't get a lot of attention. So that's very nice of him to go in there and start working on these boards. So I shared one of the patches that he's getting that he pushed in there. And that's, is Mani in here? Does Mani want to say something about it?
I don't know. Is he? I'm just saying he just happily adopts them if they don't get much attention.
Yeah,
I'll take care of them.
He takes the black sheep of the herds. Yeah. Mani, do you want to say something about that real quick?
Can you guys hear me?
Yeah.
Okay. So yeah, my intention is to provide mainline support for most of our 96 boards. So we are getting closer, and so that's why I actually thought of selecting the boards which were not given attention by our Lenovo folks. So like the Bubblegum 96 or the MediaTek X20 boards. So these are actually very good boards. So don't get wrong by just looking at the mainline support of 96 boards and then just assuming that these boards are not useless or worthless. So these are actually very good boards. As far as I know, the MediaTek X20 is the powerful 96 board we have. So it got the
Deca-core.
Deca-core SoC. So a bit of thermal throttling issue is there, but overall it's a pretty much good board. So that's why we should be running the mainline kernel on this board. So I know it's a big task, so I can't handle it. I can't push out patches on each and every day because that's not my day job. So I'm just working on it on my spare time, like the weekends and then late nights. So I'm just doing it for fun. So hopefully, for some time soon, we'll get some good mainline support on these boards. Right now, it's got the initial support.
Some of us, read. Some of us go to the movies. Mani stays home hacking at the MediaTek X20 board and the bubblegum. So awesome. You do still go to the movies though, right? Or no?
No.
I'm just messing with you. I'm just messing with you. Yeah, he says either Monty has a twin clone or never sleeps. That's what Todd says. Cool. So that was pretty much all the announcements I have. I want to kind of talk a little bit about what we're going to be covering today. So 96 boards, myself from 96 boards. I'm an alma mater, or I'm an alumni. 96. Forget everything I just said. UCSD is my alma mater. That's here in San Diego, University of California, San Diego. And I'm actually the president of the Electrical Engineering Alumni Board of Directors. And so because of that, I've had a bit of communication with some of the professors in the electrical engineering department. They asked me if I would mentor one of the senior design classes that they offer. Now, last quarter, I mentored one of the senior design classes, and they built a smart portal. So like a portal between someone anywhere in the world on the computer. There are ways to kind of like expand on this and possibly do something on your phone, but they did it from a computer to the smart portal in your home. And then that bridged off to various nodes, right? So like you could collect sensor data from various nodes running on the IoT 96 boards. That would bring them into the gateway, and then the gateway would ship it off to the user node that was requesting the information anywhere in the world. That was what they built last quarter. Now this quarter, they gave me two groups, and I was like, okay, that's that's a little more work than I wanted. However, turned out to be a lot of fun. And so this quarter, what we ended up doing was two projects. One was with the group that's here with me now. So Joy will be representing, and again, I'll let her introduce herself in a second, a self-sustainable workstation for 96 boards. And then the second group was working on a use for 96 boards in this crypto craze, right? Looking at cryptocurrency and the blockchain, we were thinking about how can we use 96 boards for this. And so I think first what we'll do, and maybe one of the students from the second project from the crypto project will show up, but if they don't, it's still okay. They gave me a presentation. I will cover the topic on their project around cryptocurrency and the blockchain, and we'll first start off with the self-sustain project. So Joy, are you there? Can you hear me?
Yeah.
Hello.
Well,
Oh, that's a nice, what is a hat? What do you call that?
oh, it's a scarf. It's just a scarf.
Scarf. That's cool. That's cool. It looks nice. Joy, usually what we do, if you could just, give us maybe a 2-minute introduction of yourself, let us know who you are.
Okay, so like you said, I'm Joy. I'm a fifth-year electrical engineering student at UCSD. I'm graduating fall quarter though. My depth is in circuits and systems, but like my focus towards electives has been computer science. Believe that's about it. So yeah.
So UCSD electrical engineering, depth in circuits and systems, and for this project, maybe you could tell us a little bit about the senior design class, like the structure of how UCSD does it.
Okay, so how the class goes is every week you do a presentation of like the progress you made so far, and then like midway through the quarter you do like a design review of it's like a it's a shorter version of your final presentation, but it's how you're like explaining what you're working on. Um, yeah, it's slides where you're just saying what you're working on, what progress you made, what like setbacks and constraints that you've like come across. But the class is very free form in that it's only basically every Thursday, but sometimes Tuesdays. But like throughout the rest of the quarter, it's just you being able to work on the project at your own pace.
Nice, nice. Yeah, and so I remember because I had to take this class, right? This was back in 2014 or something when I took it, but I hated doing a lot of like the admin work, getting the presentations done and writing up these reports and doing all this stuff. But when you look back, it really does prepare you discipline wise and multitasking wise for a lot of the things you have to do in the real world. So it's not all about just creating something. Sometimes creating something involves writing documentation and logging your efforts in a journal and doing all these things that, you know, the professors ask you to do. And you're like, why the heck do I have to do all this? Like, I just want to build my project, but you know, sometimes it's worth it. So Joy, I guess then what I want to talk to you about is I was your mentor, right? You could be candid about this. I want to know a little bit about the project, the way you understood it, and you know, possibly, yeah, actually, just give us the breakdown on your project that was assigned to you.
Okay. Well, after we had our first meeting with you, I had a better understanding of what we're working on. Um, we're supposed to build a self-sustainable kit, but as of now, it's more of a proof of concept that it could charge itself. It could also power the Dragon board, and it'll all run through a charge controller that like controls how much current goes through the battery, how much current goes to the load, and all that good stuff. Um, but uh, as of now, we're kind of just working towards putting the pieces together. Um, we sort of split into two teams where like half of us is working on the hardware, the box stuff, and the other half is working on the software, which is the Dragon board stuff. Um, so far, last night I was able to get all the wiring done, or most of the wiring done, not for the solar panels yet, but it it can still charge. I had it in the sun earlier, but the sun is now behind a giant building, so yeah. Yeah, so as of now, we're just kind of trying to improve what we have in it so far. We have an inverter, a battery, a small PC fan, and the charge controller itself. Um, Unfortunately, the keyboard, the Dragon board, and all the sensors are with the software team. I forgot to like remind them that if they could put them back in the box, so I could like show that off too. But like this is all I'm working with so far. Um,
Well, wait,
I,
let's not show it. Let's not show it off just yet.
oh, okay,
We'll have an unveil in just a second. I have a couple more questions,
okay,
and I have some comments, right? So, when it comes to this project, right? You know, there's an org at UCSD called Project in a Box,
yeah,
and Project in a Box focuses on kind of putting all of these everything you need. It's like a kit. They put it all in a box. It's a project in a box, right? How do you explain it even better than that? But yeah, so then they give them to students, you know, high school students, junior high school students, even college students, and it's bridged into college, where you can have an Arduino, a Raspberry Pi, and inside this box, it's everything you need, everything from the kit, all of the curriculum, the instructions you need to build out this project, right? But I guess what I started thinking about was, you know, we're always seem to be focused on, you know, countries or schools that have the means to do these kind of things, right? But what about, you know, countries or areas of the world or even areas of the United States that you know aren't capable of you know delivering these types of you know development materials, right, to their students. And so there's the whole idea, hey, you know, let's create this box, you know, a durable, semi, for the most part, weatherproof box that can sustain itself in most environments, uh, to power itself and to charge itself, right? So how do we get that in a compact, lightweight form, right? While simultaneously providing someone who's interested in developing everything they need to get off the ground, right? And so that was what it was, right? And so then
yeah,
that was all I gave you guys, and you guys just went with it, right?
yeah.
So I don't think I helped you too much.
Just sort of like simple stuff that we should have
Yeah.
figured out, but
All right, cool. So maybe would you mind telling us a little bit about some of the hurdles you went through throughout the process?
okay. Some of the major hurdles was some of the stuff we had that you uh loaned to us was broken. Um, there was a larger 18 amp hour battery that was completely dead. Um, there's no recovering it. Uh, the sensors were also broken. Um, but beyond that, uh, we were trying to figure out how, in one sense, how to orient like where everything's gonna fit. But we had our pieces come like over time rather than at once. So we could guess I guess we could go to the sites and like understand the sizings, but any configuration would only be theoretical. Um,
All right. Well,
another hurdle was, oh,
I was gonna. Sorry. No. Yeah. Keep going with the hurdles, but I guess now, if you don't mind, could you show us the box?
oh,
Because
okay.
Tyeth is requesting to see. It's actually not a mess of wires, I don't think.
Currently, it sort of is.
Oh.
I put it together last night and taped everything down so it doesn't like fall apart. So, let's see. So that's the inverter, that's the charge controller. These are the batteries. And this is a small fan. Everything's held down by duct tape. There's also a fuse box sort of terminal in the back just for like wiring purposes, and yeah. So right now it turns on. I just pressed a switch. So that turned on the switch to the battery. So the charge controller is now on. And the main screen just shows you like the battery level and like where the current is flowing. Since I'm no longer in the sun, there's no like lines coming from the solar panels to the battery, and since the load is off, there's no lines going to the load. But now this is where it becomes a lot of switches. I'd recommend turning on the switch for the fan first, but the light won't come on yet. And then the switch for the inverter is also like hidden down in there, so that can come on. And then there's a button up here that turns on the load through the charge controller. And so everything should be on now. Oh, except okay. So now that everything's on, the PC fan is on, the inverter is on. But another thing is it drains the battery very quickly. So it's a safety mechanism of the charge controller, which just turns everything off really fast if the battery doesn't have enough voltage. So it switches all the loads off.
Tyeth says, held together by duct tape, a sign of a truly great engineer. Give Joy her PhD now. But so Joy, this isn't going to be with duct tape tomorrow, is it? When I go in there for the final review? The answer is no.
Yeah, it's what Karina and I can come up with tomorrow.
Okay,
we're gonna
cool.
need
We'll see.
basically Velcro to like replace all the duct tape. But...
Yeah, so there's a double-sided Velcro. I think I have some around here. Maybe we can pick some up tomorrow. Either way, that looks awesome. That looks awesome so far. And I think a question from Tyeth was what he wanted to see or know was also what screen are you connecting and how much power does it consume? So I know the name of the screen, but I'll give this question to you. Do you know it or should I just say it?
I don't remember the name of the screen,
Okay.
sorry.
So Tyeth, it's a WaveShare 5-inch WaveShare screen. WaveShare is a common screen for Raspberry Pi, but it works very well for most 96 boards as well. So we've adopted it and used it for this project. And if you show real quick, Joy, could you show the project again, the box one more time?
Yeah.
So you can see where the screen goes. The screen gets mounted right there, and it comes in through the back side and then screws in. And then I'm wondering what those 4 circles are on the right side. Are those going to be knobs, or those are the switches?
That was originally for the switches, but like since the switches have sort of terminals on the end of them, it extends the length of them, so it doesn't actually fit through the holes. So we have to make another compartment just for the switches, probably connecting it around here next to the batteries.
Okay, cool. Yeah, and so basically for this project, what they had to do was calculate, you don't want to take 5 days to charge enough battery to basically use your system for 1 hour, right? So like if I have to spend 5 days in the sun just to use a system for 1 hour, it doesn't make sense. So a lot of the calculations had to take place to kind of make it at least somewhat efficient, the most efficient possible for a decent price, right? Because at the same time, if you're talking about some sort of, venture that caters to underserved or underserved areas of the world or the U.S., you end up, obviously wanting to make it as cheap as possible. And so I think right now, what are you looking at with regards to the specs, Joy?
So currently we have a 12-volt, 9 amp hour battery, which is 108 watt hours. Um, to chart to run the Dragon board alone, it's about 25 watts. And if we want it running for like 5 or 6 hours, well, it's the load as we calculated was for the fan, the Dragon board, and the screen, which added up to 30 watts. And then to run that for 6 hours, 180 watt hours. So right now we're under what the watt hours needed if we wanted to run it for 6 hours. But it can run for fewer hours than that.
Yeah. So looking at, what is it? Ohm's law equation, P equals IV, current times voltage. You have the Dragon board, which power supply is 12 volts, 12 volts, 2 amps, right? So that's 24 watts. That's at max capability, max capacity. In most cases, you're not going to consume the full 24 watts. In fact, I don't know what do you think? What's actually the full pull that you're trying to?
It doesn't consume that much. The 12 volt 2 amps is for the whole CE spec itself. So I think more powerful boards like the 960 or even the 820 would consume somewhere close to that, but I don't think Dragon board consumes that much. The CPU itself, with all the 4 cores running, is kind of rated at around 3.5 watts. So I'd go for more of a 4 watt CPU kind of a rating. So it shouldn't consume a whole lot of energy.
Yeah. So I think you're still in good shape. I think the only way you're really going to consume large amounts is if you have every peripheral consumed, right? Like if you're using all of the USB ports and all of the IO ports and everything that you can get your hands on, you're consuming, and that might end up using more power, reducing the amount of time. So the goal is to replace that battery, the 9 amp hours, with 18 amp hours, and then that would hopefully provide you absolutely enough to keep it powered, right?
Yeah, it would be over 240 watts.
Yeah. Cool. So is there anything else that you have to say about the system, or anything else you want to talk about the system?
I wish it wasn't so many wires, but it was fun, like putting it together. I had to draw it out because once I realized that, you can't just you can't just eye match where each wire goes initially. It was just fun to figure out.
Yeah.
At least for me.
So there's 3 things I think we want to address here. One, Todd Thal mentions the ability to possibly throw a post up with a solar panel. This is something that a village would have to think about, right? So if they're acquiring, say, 100 of these kits or 50 of these kits for a group of students, or some, I've worked with other programs at UCSD, like maybe a container-based education facility, right? Then on their shipping container-based education facility, you could host solar panels. Those solar panels, then what would happen is the kids would take their kit home for the night, right? And then every day they'd go into school, they could plug their kits in, charge it throughout the day, and then take it home at night, right? So kind of stuff like that. One of the issues that we always found when dealing with some countries that are like out in these tropical areas, right? There's these villages with several hundreds of people, and you're trying to bring technology to some of these villages, but the problem is that we're not used to dealing with such crazy temperature fluctuations and humidity and all of these different things. So as students, I was a student working with programs in Fiji, stuff like that. You end up designing and then really learning about how you need to cater to these areas. Not only that, you'd be surprised at how often things just get destroyed from like a natural disaster, right? So, you put out a solar post there, and then a typhoon comes and it's gone, right? Like within 3 months. So like there's a lot of factors that have to be taken into account. And I don't obviously there's also the thing that people break it and steal it, right? So it has to be monitored and very treasured by the community for it to be able to, if the community doesn't want it or need it, then they're not going to care for it, right? So it has to really, you have to really set the ground for it, the basis for it. So next thing, Tyeth has a question here, or I mean, it's good, we should continue on this, but I kind of want to know also, did you have any more hurdles? You were about to say another one that we stopped you on.
I don't remember at this point.
Okay, hurdles. Okay, hurdles check. Sorry, Tyeth. And then let's talk about other things that you might be interested in adding to this box.
The only improvements I could think of now are just like regular quality of life things. I like, for one thing, a lot of the wires lengths weren't measured, so I just kind of try to make them the same length, but I didn't know how long any of them would need to be, and that means like a do-over of a lot of the wires. Um, it would be nice if there was like a pull-out stand as well for the keyboard, because as of now it would just be the keyboard itself. Um, and I guess covering up a lot of these components would make it look prettier. But other than
All right.
that, yeah. Other than
That's
that, it would
good.
just be replacing like the battery to make it larger.
Yeah, and so
So
something. Oh, sorry. Go ahead, Sash.
yeah, I was saying the wire bit kind of reminds me of the Carbon rover project because I like started with those jumper cables and then they became super long and weird, and then I had to rewire them with much thicker cables than I expected them to be, and finally I ended up wiring with the cables that you on your screen right now, which are much thinner. So I think I had to do the whole wiring and measure the lengths every time. It was kind of weird, but yeah, you learn a lot.
Yeah. And I still need to fix your Carbon rover. The airline destroyed. So Joy, what about this? This is, I think, something that would be interesting. Well, first of all, also, we didn't really mention, you have the other section of your team, the software side of the team that's building some other sensors, right? Or that's working on the sensors. The goal of this kit was also, right, to provide some sort of readout of the humidity and the temperature of your area, right? Without needing, like, imagine you don't have internet access and you want to know what the temperature is or what the humidity is or certain various aspects of the ecosystem you're living in, right? I can't just get on my phone, or I can't just search the internet. So those sensors will be included in the box and reading out constantly to your Dragon board or your 96 boards. But Joy, what 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 did you learn, if anything, from this project? I'm kind of interested in this.
I learned more about charge controllers, uh, and that like how they start up and how they can have like so many errors going on if you don't know what you're doing when you first start it. Um, I learned more about, I guess, battery sizing. When we were in like the research phase, I found like a really good site that told me like, well, it helped me do the math for like what kind of batteries we would need and like how the math works out. Um, Other than that, it was just a lot of Googling over time, just of like basic concepts that I thought would help. Um, and yeah, it was
Nice.
just, yeah.
Yeah, I remember my first time working with solar project was so my project for ECE 191, that's what it is, the senior design project, was a solar project. We built a solar RV right? So like a trailer that was being tugged by in a truck, we adopted it to be, completely sustainable on itself, solar wise. Yeah, you do learn a lot about pairing, right? And this kind of leads into Tyeth's question here. And then we'll start winding down on this part of the segment, Joy. We'll let you get back to your finals and your classes and stuff. But I guess Tyeth says, does the charge controller support additional panel connections in addition to the existing used? I'm trying to understand that question. I think it's basically, can you expand on the project by adding more panels, right? So take that one.
Yeah, so you can add more panels. There is just a port for solar panels, plus and minus. You can actually just add any DC power source to that port. I've tried with like a DC voltage generator, and that's what like I've been half using to just check if this works to charge the batteries. But yeah, you can, as long as the panels match, I guess, you can like add as many as you want.
Okay, cool. Yeah, so I'll elaborate a little bit more on that too. The charge controller, right? Usually, in most cases, you can get a $5 charge controller, or you can get a $1,000 charge controller, and that all is going to kind of depend on how many amps it's capable of taking in, right? So I think the two panels that you have are 0.65 amps each, something like that. So if you run those in parallel, it adds up and you get 1.35 amps. Did I add that right? 1.3 amps? Yeah, 1.3 amps. So if you add that up, you get 1.3 amps per hour. If you have 8 amp hours or 9 amp hours on your battery, it's going to take you roughly 7 hours to charge your battery, right? But you could take another one of those panels, add it in parallel, and then you have 2 full amps, in which case then it would take 4.5 hours to add your battery. However, the charge controller I think that Joy has is 30 amps. So you can only add as many parallels until you hit right around that 30 amp spot, at which point the charge controller could short. You could destroy your charge controller. And so a lot of times what Tyeth is asking now, do you match in terms of size and wattage? Usually the specs are matched based on amperage and wattage, but I would say for the most part, it's voltage and amperage. Sorry. So volt and amperage. Yeah. So that charge controller is a 12 volt, 24 volt charge controller.
Yeah.
Yeah. And the inverter is a 12 volt inverter. So an inverter brings it up, a converter steps it down. And so the inverter brings it to, wall socket voltage, US wall socket voltage. And then the charge controller can handle, I believe, 12 volts, 24 volts, and a max of 30 amps. And then what the panels, I believe, are 20 volt panels or something like that. Yeah, I don't remember, but it's something like that. It's like it's some weird number like that, right? But so that's why the charge controller is 12 volt, 24 volt. So the closer you get to one of those numbers, the more efficient it ends up being, right? So you can get panels and you can kind of like put them in parallel / series to try and maximize your efficiency with your entire system. So the closer you match the components, the more efficient your system will be, right? With less loss. At least that's been my experience so far, and I've developed several solar projects, solar generators. And then another question, or a question from Todd, is anyone have any contacts with Elon Musk? I wish. That guy's like, he's super cool. I look up to him a lot. He's got awesome stuff also happening on his social media. He's a real funny dude. Yeah. Do you have a contact with Elon Musk, Todd? You should introduce Joy. Get her a job at Tesla. Yeah. Joy, do you have a job lined up already?
No, not yet.
Actually,
A lot of
I do
jobs
have
are
a
just
headhunter
like either
contact
during the
I'll
summer.
have to get the email. Sorry about that, Joy. Yeah,
Oh,
I
sorry, Todd.
actually do have a headhunter contact. I was contacted by Tesla Manufacturing. I'll try to dig it out if you want. give it to Robert or somebody.
Yeah, that'd be cool. You know, I wish I could hire all the students that I mentor at UCSD, but 96 board is such a small team. So that's tough. And so Angie says he is always shopping for battery research and improvement. That's what he said in his shareholder meeting. So yeah, referring to Elon Musk and Tesla. Great. So Joy, I guess we're going to close out this half of the segment. Is there anything else that you want to add to this, or you know, and you can feel free to go after if you like.
Not really. It's just a really fun project.
Cool, cool. Yeah, I'm glad you liked it. You have to say that to get your A, right? Yeah. No, it's been a pleasure working with you and your team. I will say, you know, what was it? Other people on the team. There's 4 people on the team. You have been the most communicative. I mean, you know, we text together and you know we talk and call, and you know I'm really glad that at least you took the initiative to make sure that communication was happening between the team and myself. So thank you for doing that. It's actually that's a positive trait to have, to be able to communicate and speak for your team. So, you know, good job.
Thank you.
Yeah. Cool. Well, Joy, thank you for showing the project. Do you mind just kind of giving us one last look before we go on to the next topic? There's the solar kit being built by the UCSD students. You can see it's a little handheld Pelican box, and it should be self-sustainable. The solar panel is clipped onto the top. Could you maybe like push that down just so we can see the solar panel? Yeah, see there's a solar panel on the top. There you go. Cool. Thank you, Joy.
No problem.
All right, we'll talk to you next time, and feel free to stick around, or you can go if you have other stuff to do.
I need to go get breakfast.
All right, I'll see you tomorrow on campus.
Yeah.
All right, cool. Thank you.
Bye.
Bye. All right, so next segment, what I want to do is I want to talk to you about the blockchain. All right, so I'm not sure who here is familiar with cryptocurrency or the blockchain or what the heck it is, but all I can tell you with I'll give you a little brief summary of the way I look at it. Okay. So blockchain technology, revolutionary technology. If you haven't done your reading or research, I don't have enough time to exactly explain the blockchain to you, but I will say it is revolutionary. It's a big deal. And there are a lot of companies that are coming out now trying to capitalize on this blockchain technology. 96 boards. How do we factor into this? Well, why not? I mean, there's so many things going on, and there are so many companies going out there and trying to build technologies around the blockchain, but there are very few products. So if you look at the blockchain in general and all these cryptocurrencies, you can go out there and you can get these cold storage wallets, or you can go buy a bunch of GPUs and throw them on a computer and run a miner for proof of work. But what other products could exist around the blockchain? And I bet I'm talking to a lot of people right now, or some people are watching this, and they would say, well, I don't know about the blockchain, or I don't know about cryptocurrency. I don't know anything. That's the whole thing, right? There is such a kind of gap right now between the novice user or someone who wants to get involved in crypto or blockchain and the fact that it's just so unattainable. So a lot of people don't know what the heck is going on, and how can we create a product to kind of bridge that gap, lower the learning curve, lower the barrier of entry for people who actually want to start experimenting with this stuff. Not necessarily, we're not talking about experimenting at, say, okay, I want to invest tens of thousands of dollars, but like getting used to, getting familiar with how the blockchain works and how to use these cryptocurrencies for transactions, if you want to talk about it in that way. Cryptocurrencies, a transaction being either monetarily or a transaction of data, right, across the blockchain. So I'm going to share a presentation here. Actually, I should pull it up on this computer so that let me see what I got here. I just need 1 second. Gmail. But basically, the whole idea was that we wanted to create a product around using 96 boards and focused on cryptocurrency. Now, one thing I want to mention before I go into this presentation, which I'm opening, is that when you think about the last big technical revolution, right, that we had back in the late 90s, right? I'm sure a lot of people remember this if you're old enough. I was actually 15 years old when this happened. So I was given the opportunity, my dad being the cool dude he is, I had a college fund once. And he basically said, son, what do you want to do? Do you want to keep your college fund, or do you want to invest it in stocks? And I'm like, oh, I'm 15 years old. I want to invest it in stocks. So I bought, Dell and Yahoo and Microsoft and all of those. What is it? It was CDMA, not CDMA. There was another company that a bunch of these tech companies, and I was, oh my God, I'm so excited. I took my $20,000 or $15,000 in college money at 15 years old, and it turned into $100,000 in like a month. All right. And then the next month it turned into zero. so that's how, and I got greedy, right? But that's how quickly you can make money in the internet market, right? So from what I read is the internet or the internet boom of 2000 or crash of 2000 brought the market up to $6.7 trillion. Did I freeze?
That is fine.
I'm fine. Okay, great. So brought the market up to $6.7 trillion. Okay. Now we're looking at the blockchain and the technology, and it is, according to most people, revolutionary technology. So if you're looking at a market right now, the whole entire crypto market being at about 400 billion, all right, we still have a long ways to even make a mark compared to what the internet market was back in the 2000 before the crash, 6.7 trillion. Take into account inflation, right? Take into account that this technology might have never allowed the internet to crash, the internet boom to crash in 2000. Maybe if the blockchain existed in 2000, we would have not had the crash. There's a lot of things that we can speculate, but the one thing that I can, at least put my money on is that 400 billion is a very small amount of money when you look at how much money is in the world. And products, people are going to want to buy products around this, and there's nothing that exists yet. So I feel that putting some effort into developing products that people who work on the blockchain, people who are using this technology and studying this technology, or people who are working with cryptocurrency, these products have a lot of potential. And that is where I'm looking at it from. I am invested in some cryptocurrency, but I'm looking at it at a product standpoint. People who can come in, develop products, real tangible things that people can purchase and use to accent or supplement or complement their experience while working with blockchain. And that is what I'm going to share right now. So let me put it in here, events 2018, UCE 191, spring. My folders are a maze. I don't know how I get through them. All right, so UC presentation. Share screen. I'm gonna try to summarize this the best as I can, because this is not my presentation. I'll remind you, this presentation was created by the students, similar to Joy. There's a group of 4 students. You can read their names: Andrew, Chen Cheng, Ode, and Richard. They took on the task of creating a more user-friendly kind of product, right? So now what we want to build is we want to take a 96 boards, we want to put it in a black box, and then we want you to plug the 96 boards in, and then welcome to the world of crypto. That's basically it. Follow your path. Take one of those books where you create your own path, right? And that's kind of the idea. So a little overview of the project is we want to create a customer-friendly product, or the students are doing this, create a customer-friendly product that removes the barrier of entry to cryptocurrency. We're going to focus this presentation on Bitcoin because it seems to be the more familiar name, and along with Bitcoin, a coin that we're going to use, which uses the Bitcoin blockchain, called SmartCash. So SmartCash is a type of cryptocurrency. I spilled something. All right. So it looks like I don't have a lot of time. I might just brush over this. But the idea is to implement this product on the ARM architecture, right? All right. So what is cryptocurrency? Decentralized. It's a decentralized network or blockchain that has no control by any one individual, right? So there are no governments or institutions that can control this. No one person can control this, right? What you would normally see is in most institutions, or most ways that our financial system works, is you have a central institution that brokers all transactions. I want to send money to John Mark. I take my money. I have to have a John Mark said, yeah, please, everybody. Yeah, I need multiple institutions to confirm the transaction on its path to John Mark, right? But all of these institutions are centrally controlled, right? So what we do is we now decentralize this with the blockchain, and we use a public ledger for our transactions. So the best way that I've found to explain this in a group of people is that I'm standing in a classroom and I grab a bottle of water, and the whole classroom is full of people. Okay, I want to pass this bottle of water to someone on the other side of the room because he or she is thirsty. So I hand it to the person in front of me. They hand it to the person next to them. They hand it to the person next to them. And eventually it makes it to the person on the other side of the room, right? But how does each person on the way to that last person on the end of the room know that it's a true transaction, that it actually should have gone to that person? I said I want it to go to that person. That person on the other side is going to accept it. On its way there, all of the people around, each time that bottle of water changes hands, observes this transaction. All right. So it observes the path that it's being taken, right? So each person in this network of nodes gets to approve the transaction as it makes its way across the system, right? And that is somewhat similar to how we would look at the blockchain. Now, every transaction, of course, gets logged. That is the ledger. You can picture that as kind of a list. I am going to really kill myself if I try to explain all of this in 2 minutes. So I'm going to skip what the blockchain is. Again, I would suggest looking it up. Exchanges and wallets. This is something that, can be talked about in another OpenHours episode, focusing on SmartCash. This is the coin that we chose to address in this project, right? So the UCSD students are going to be using SmartCash. We were given a gracious donation by another UCSD alum who allowed us to kind of play with some SmartCash cryptocurrency to make this node work, this 96 boards black box work. And we were able to both create a hard wallet, but also, I'll tell you something, these students, they were able to make a brand new type of system that verifies transactions completely independent of an internet connection, right? So this is, again, basically talking about products that exist, okay, and products that don't exist yet. If I have a cryptocurrency, like if I have one Bitcoin, right now, Bitcoin's worth like $7,700 or whatever. I take one Bitcoin, that's a lot of money. I don't want someone to steal my Bitcoin. I don't want to lose my Bitcoin, right? So how do I safely move this Bitcoin from one place to another? Or how do I safely store my Bitcoin, right? If I'm connected to the internet at all times, there are many ways for people to socially engineer their way into my system, or hack my system for that matter. They can get access to my passwords. They can get access to all sorts of stuff. And we try to, up our security with multi-factor authentication and all this kind of stuff. But eventually, there are vulnerabilities in our systems. If you're not connected to the internet, you can't get hacked unless someone comes in and hardlines you, right? That's how they'll get your stuff. So what these students came up with is pretty genius. What they did is they took the 96 boards and they created this black box, and they put the private signature for all transactions happening for those currencies on your black box. And then it just runs in a loop. So anything you're doing on whatever blockchain you're working with, whatever cryptocurrency you're trying to send, you perform your transaction. You take your signature page, you put it on a thumb drive, you bring it over to your 96 boards, pop it in for 3 seconds, unpop it, it signs the transaction, bring it back over to the internet connected device, and then the transaction's authenticated. Okay, so basically this is something that allows people to feel 100% secure about their assets that are available, because you cannot send, receive, do anything without the private key. And if your private key is not on the internet, then no one can get it. And so what happens now is there's cold storage wallets that are out there that require you to be on the internet to store your coins, right? There are vulnerabilities in that, right? So this product that we're talking about, one of the first steps, has already taken down barriers of security, or has already added barriers of security that has not been seen yet, right? And that's just one step. So the next step is what we want to do is we're going to be adding a node function for multiple blockchains. We'll be adding a node function. We'll be adding more coins to the wallet function, and we're going to be adding a mining function. So there will be all of these features added in there for you to do proof of stake mining, proof of capacity mining. You're not going to do proof of work mining with these boards. Sorry. So, and honestly, that's not really a good system, in my opinion. It burns a lot of energy. So proof of stake, proof of capacity mining, and then you'll get the opportunity to hopefully experience a more user-friendly barrier to entry for crypto. I still have this going. Sorry, I forgot. So 96 boards as the SBC. This is the Dragonboard 410C that they're using. They've emulated Debian for development. So basically, they did all their programming on a host machine, and then it just seamlessly moved into the Dragonboard, right? So this is kind of an example of being able to work on Debian and then just moving into the Dragonboard. Here you can see kind of some of their setup and how they're managing this, along with this device, which actually they have. I wish that they were here to show this. It's going to also have a somewhat of a stock ticker, right? So like the various cryptos that you are holding in your device, if you want, you can connect it to the internet and you can have it pull data from, or you can have multiple devices. What they really want to do is they want to have multiple devices, one you carry with you and one you keep at your home in like your vault with your private key. The one you carry with you can keep you informed on what's going on, and then if you ever want to send something, you have to just get the private key off your secure device. So this is some of the code that they had to do, some of the use of the API for I think they were using Binance API. I'm not sure, one of the crypto exchanges, using it as a cold storage. Again, I'm not going to go too much into this. Unfortunately, we're at the top of the hour, but this is how you could recreate it. This is their flow chart. This is some of the hardware they're using. Talking a little bit about 96 boards, and then they would have had a demo if they were here. So sorry, that's all I have for you. Now, what I'm going to do is I am going to have a specialist come in and talk about the blockchain in one of our later episodes. I don't know which one it's going to be, but we will have a blockchain specialist coming in here to talk about that. And yes, the presentation I can share, Taya. Also, the GitHub account is under the 96 boards 96 boards projects. No, 96 boards projects. There we go. I'll share the projects page for the crypto node. I don't think they have it completely up there yet, but you can go see. Oh, so yeah, the current goals, current progress. Looks like they've slightly updated it, but they will be putting their final updates by next week. And you can follow along how they built this crypto node out. Ultimately, the goal is you boot it up, you get 3 options. What do you want to do? Wallet, node, or mine, right? Wallet, just you store your stuff, cold storage. Node, you improve the blockchain, you improve the network by offering a node. You're now one of those people in the classroom passing the water bottle and verifying the transactions, right? So noding can serve a purpose. 1, by improving the network, right? 2, by even earning money, right? So like you can node as a master node, and every time your node is used for passage, coins get dropped into your wallet, right? So there's also ways to earn passive income by doing this. And then 3 would be mining. So then you would have these options, hopefully with a very strong, very friendly user interface, and you can start playing with crypto. That's the goal. And this product obviously doesn't exist yet. And if anyone's watching this and wants to hire a huge team of people to work on it, then they could probably get it done faster than us. And feel free to use our repo to get started. Yeah, so that's it. I feel like we should do an episode on just crypto and blockchain and just have a big old talk about it. Does anyone have any questions before I close this out?
I think for the proof of work, I'm not sure how many cryptocurrencies out there are now profitable on GPU, but I mean, it should be possible with the developer box, given the amount of PCI lanes it has, and that it is compatible with uh, fairly powerful GPUs.
Well, so coins like the Bitcoin, right? Coins like Bitcoin.
Yeah, that's out of the
Bitcoin.
question. Yeah.
Well, yeah, what's happening now is, at least depending on where you are in the world, right? Because energy costs are different. You know, if you're harvesting it from solar energy, what's your computer being powered off of, et cetera, et cetera. But from what I understand, on average, each Bitcoin is costing over $6,000 US dollars to mine. So if you're looking at the cost of the Bitcoin being 7,700, we're getting awfully close to a Bitcoin being worth what it costs to mine, right? That's a big step. It's a big step in crypto market because, you know, you're not super inflated, right? Like, you know, what was it back in December when the Bitcoin was at almost 20,000? That was like super inflated at the time. And, you know, everyone's talking Lambos and moonshots, but it's you know, reality is that, you know, getting closer to the actual value of what it costs to mine is actually, I think, nicer. One other thing I wanted to add is, like, you know, I really enjoy the crypto market, at least a lot more than, you know, what would you say, the stock market? Not because it's unregulated. I actually don't mind it being regulated. If the government wants to come in and, you know, start taking their fair share, as long as it's fair, you know, whatever, can't do anything about it. Regulate it. That's fine. It'll make people feel safer to play with it. But a lot of people misconstrue cryptos as some like fake entity, right? But in a sense, all you're doing is you're just investing in a technology company. You know, like, it's no different than investing in, back in the day, investing in Yahoo or Facebook. You're buying shares of a technology company, but your share has a utility. So, like, imagine if you could go to the Dow Jones or wherever Facebook is hosted, NASDAQ, I'm not sure, I think it's Dow Jones, and buy Facebook shares, right? But those shares just sit in a portfolio and you can't do anything with them. They sit in your E-Trade account or your Ameritrade account. You can't do anything. Now, imagine if you bought Facebook shares, but you could use them on Facebook to, like, buy ad space, or I don't know, on Amazon to purchase a new computer. Like, I own a share of Facebook and I want to use it for something. I don't want to trade it back into dollars and then use it in dollars. Like, I own a share, it should be worth what the share is worth, and how come I can't use it? That's what these technology companies are doing. They're giving you a share of their company, but they're also providing the utility for their share. And that, I think, is pretty amazing. I no longer have to hold on to, you know, a pile of cash. And hopefully when these applications and stuff start coming out, the dApps, decentralized apps, you know, there will be more use for these coins. And if Amazon or one of these big companies start taking any of these coins, then you'll start to see true utility behind them, right? Facebook, I heard, is, you know, working on blockchain research. And, you know, if Facebook moved over to the blockchain, I mean, just imagine, right? Like, it'd be very easy for them to tokenize ownership of their company and allow you to use it across their website for different things. You know, every time maybe you like a photo, you could give them a Facebook coin. Shit, I don't know. Cool. So Todd says, smart idea, Robert. Sounds a bit analogy, not literally, like two-phase commits in SQL for financial transactions. Yeah, you know, I guess you could kind of look at it like that for the product idea. Yeah, the whole goal though is to kind of, that's just one aspect of it. So we want this to be like an all-encompassing product, right? Tyeth says the difference is your middleman can be hacked and isn't covered by insurance. Yes, that is true. So if you have a middleman, being a bank, the bank is central. The bank can be hacked. Anyone can be hacked, I guess, nowadays. I mean, like, it seems every year, right around Christmas time, one of these big retailers gets hacked, and hundreds of millions of dollars, along with tens of millions or hundreds of millions of people's sensitive information gets compromised every year. Like, I mean, what was it? Last year it was Target. The year before that it was Home Depot. The year before that it was Target again. And just, I'm not sure. Don't quote me on that. But like every year it's some big company that gets hacked. And there's nothing you can do about it. Tyett says, still over here, UK, most things are only covered up to first 50,000 pounds, or what we'll say quid, 50,000 quid, someone's savings. Yeah, companies are starting to work with the federal government, at least in the U.S., like companies like Coinbase, to get to make people feel more secure in their investments. And I'll tell you right now, as soon as there is a safe place to host my money on the blockchain in the form of a cryptocurrency, goodbye banks. I'm done with you guys. Been ripping us off since the day things started. You know, the banks have been ripping us off, putting our money to work for them, not for us. You know, so that's my 2 cents. Hopefully, no one works for a bank. Anyways, I guess we'll stop the recording. No more questions. Nada. Okay. Next week, we will be meeting with 96 boards open hours. If you guys haven't noticed, on the open hours webpage now, we have a episodes tab. I just spent a bunch of time yesterday updating the episodes tab, so you can see what's coming up next, hopefully for the most part. And next week, we're going to be talking with Tom Cubby from Vammers. He will be introducing the Rock 960. So this is the first time, other than Lenaro Connect, that we've had someone from a partner company come on and talk about a new product. So Tom Cubby will be joining us. They are the Vammers is the company that built the Rock 960 around the Rock chip. They'll be talking about the Rock 960. I will have my Rock 960 out, hopefully running some fun application. If not, Tom Cubby, I've been told Tom Cubby will have a demo to show us as well. So stay tuned for that. You can watch it on Blue Jeans, on YouTube, on Facebook. We look forward to talking to you. Anyone who is on YouTube right now, feel free to move on over to Blue Jeans. The link is in the description of the YouTube channel, and come yell at me about my views on blockchain. All right, stopping the recordings now. Sahaj, let me just hit the recording button off.
Recording has stopped.
And now I'll do Facebook Live off, if I can figure out where that is. Oh, here we go. So stopping Facebook Live. Bye, Facebook. Thank you. Tune in next week. We'll talk with Tom Cubby from Vammers about the Rock 960. Did I not hit it right? Okay.
The broadcast of Facebook Live has stopped.
So Sahaj, are we ready to stop the YouTube?
Yeah. Bye,
Okay, bye, YouTube. Thank you.